Chapter 17 Physics, question number 3 and 4. Question number 3. Explain why all the velocity arrows in figure 17.5 are drawn the same length. So they are referring to these arrows, the three arrows here. As you can see, the red arrow inside the red circle, they have the same length. So why do they have the same length? They have the same length because their values, the numerical values, are not different. They have the same numerical value. That is what it represents. That is, even though the velocity is changing. Why does the velocity change? Velocity can change due to two different reasons. One is changing of the direction. The other one is changing of the numerical value. But here the numerical value remains the same, but the direction is changing. That is the reason why velocity is changing. But the speed, the scalar quantity, it doesn't change. The scalar quantity remains the same. Therefore, the lengths have been drawn equal in length, in the same length. I hope you understood that. Then question number 4. A toy train travels at a steady speed of 0.2 meters per second around a circular track. Figure 17.6. Let's go to figure 17.6 and see. So this is figure 17.6. As you can see, a toy train is traveling around a circle. So at point A, as you can see, it has a speed of 0.2 meters per second. At point B, it has the same speed, 0.2 meters per second. But now the directions are different. So at this point it is traveling downwards. At this point it is traveling upwards. Right? So those are two facts that we need to understand. So now coming back to the question. A and B are 2 points diametrically opposite to one another on the track. Determine the change in the speed of the train as it travels from A to B. So that is part A. Determine the change in speed. So speed has no direction. So how do you find the change in speed? From the final speed, you subtract V minus U. Final speed minus initial speed. So let's do that. So the final speed is 0.2. Initial speed is also 0.2. So the answer is 0. So the speed does not change. It is quite simple. Then we come to part B of the question. Determine the change in the velocity of the train as it travels from A to B. Change in velocity of the train. Now we have to be very careful because the velocity is something that has a direction. So in this particular moment, if you take the downward direction to be positive and the upward direction to be negative, you have two different values. Then from in one direction minus the other direction. So let's try to find the change in velocity. Change in velocity is equal to, now in this particular situation, plus 0.2. Then from that you subtract negative 0.2 in the opposite direction. Then this minus to minus gets positive. 0.2 plus 0.2, it would be 0.4 is the difference in velocity, because the directions are applied here. Hope you understood that. If you have any questions, please raise questions.